In this first video, we'll talk about the concept of thermodynamic efficiency and hopefully develop an intuitive understanding of this concept through the use of everyday examples. Okay, so in this first example, imagine we are going to a jewelry store to purchase a gold necklace. And the gold necklace is priced at $1,400. We go to our lab and measure the weight of the necklace, and we find that's an ounce, exactly an ounce. And we want to know what's the efficiency of this process. So at first glance, this question might seem strange, asking the efficiency of buying a gold necklace. But I think you can draw an analogy to thermodynamic efficiency. In thermodynamics, we are typically talking about converting energy from one form to another. For example, if you have a light bulb on for a few hours, you're converting electrical energy to light energy, and some of that energy is lost as heat. In this example, we're talking about converting money from one form to another. So in this case, we have money in dollar form in terms of notes and cash, and then in the second form, the money is converted to gold. So let's go ahead and start solving this problem. So in this case, you have an input, and you started with $1,400 in cash, and then your output is 1 ounce of gold. And the question is, what is the efficiency of this process going from cash to gold? So here's our solution. And there are two approaches, right? One approach is converting everything into gold, and the second approach is converting everything into dollars. So in order to find efficiency, so efficiency is just times 100%. How much money you invested in it, what you got out of it, is essentially our efficiency. So again, as I said, in order to compute this ratio, we have to make sure that input and output are in the same form. So they could either be both in the forms of weight of gold, or they could be in the form of dollars. So let's start with gold, right? So if we convert exchange rate market, our exchange rate is, for the free market, it's 1 ounce of gold is equivalent to $1,260. So that's the exchange rate in the free market. So in order to convert the cash, $1,400, so we have to convert both input and output in terms of weight of gold. So we have our efficiency. Okay, so we know the conversion rate. So we know our input is $1,400. And if you try to convert it into gold, you have to multiply 1 ounce of gold over $1,260. So that gives us 1.11 ounce of gold. That's our input. Our output, we know already, is 1 ounce of gold. So our efficiency for this process is output over input Our output we know is 1 ounce of gold, and our input is 1.1 ounce of gold. So if you compute this number, this comes out to be 90%. So let's repeat this example. So if you are looking at dollars, we have to convert everything into money units. So let's look at this example. have our input is already in money. Our output is the units of gold. So we have to convert our output into money. So we know our output is 1 ounce of gold, and then we know 1 ounce of gold is equivalent to $1,260 over 1 ounce of gold. So our output is $1,260. Our efficiency again is input over output, output over input. Our output is $1,260. Our input is $1,400. And if you compute those numbers, this turns out to be 90%. So again, both methods are equally valid. You just have to make sure you convert. We just have to make sure we convert input and output into the same form. And they could either be both in the forms of gold, or they could be both in the form of dollars. So one of the new things we are trying is that we are incorporating some questions along these videos. So the next question I might ask for you guys, and you will have to answer that in the pop-up screen, is what if the efficiency of this process was 95%? So we know the efficiency, and we know that we got 1 ounce of gold. The question is, what is the input? Alright, so I'll go ahead and let you guys answer this question.